I am repeating this, which I have told earlier also, that you are going to have your test series starting from October first week. Those who are not knowing about this. By September end, from our side, syllabus, revision, everything will be done. And from October first week, we are going to have our test series starting. The people who have joined late will continue to attend the classes and learn the topics. But the people who are coming from day one, we want to train them more for facing the board examination. So from October first week, after Vijayadashmi, that is 2nd October, I think 3rd October something, there onwards you will have your test series starting. Test series will happen as if every week you will write one science test, one math test, and you will be having discussion class based upon that. When you write a science test, you will write physics, chemistry and bio in that. So you will have one physics class, one chemistry class, one bio class to discuss about how the paper was, what could have been written, where you went wrong, and math test and math class. So in a week, you will have 4 days of class and 2 days of test. It starts from October 2. And believe me, that is the most important phase of this journey. If you are serious in that October, November, December, January month, you easily can score 95 plus and you can aim of 100 marks also. Whatever is happening till now is just 2% of what is required. 98% of efforts will be taken during October month only. Remember that. So learning is one thing, execution is another thing. Learning you are doing, but how to face the examination, how to face the questions of new type, where you may go wrong, what you should avoid in the board examination, that training will be given rigorously for 4 months. October, November, December, January, 4 months you will be trained and you will give different types of test. First we will give chapter wise test, then we will give mark wise test, then we will give full portion mock tests. It goes like that, if you are understanding. So, one second. Okay, so I hope you are understanding this, whatever I have told now, how the program is going to go forward. I hope you are understanding that. And as I said, today we are going to have a revision of which chapter? Electricity. So those who are writing for the first time or writing continuously can give the heading as electricity once again. Today we are going to revise electricity chapter. Okay, so nothing to write much, just listen today, and again I am repeating, it's a recap of the whole chapter. If you have doubt at any point of time, stop me and ask me what is that. Okay, at any point of time if you feel there is a doubt or something not clear to you, stop me and ask from me. So as this chapter starts, electricity, also called as current electricity or also called as electric current. So the first topic which comes in the mind is what is the meaning of the word current. And what is current? Current means flow. Flow of anything. It is flow of water, it is water current. If it is flow of air, it is air current. If it is flow of sand, it is sand current. If it is flow of charges, it is electric current. So current means flow. If it is electric current, it means flow of charges, not flow of electrons. Generally we say flow of electrons because electrons are more mobile. If you know about the nucleus structure of atom, the protons are positively charged but they are located inside the nucleus. Being inside the nucleus, it is very difficult for the protons to come outside and participate in mobilization, participate in movement. So what happens generally? It is the movement of electrons which decides the current. So that's why in some books you will find the word current electricity is flow of electrons. But to be very precise, it is not correct. Because even a proton, even a positive charge, if it moves, it is going to produce current only. So whenever charges are moving, it produces electric current. Give me a second. Rayan Ahmed, are you able to hear me? I think there is a problem in that connection.
Yes, sir.
You are able to see me? Darshini, Vaishnavi, Shreya, Preetam Vadi, everybody is able to hear and see me?
Sir. Yes, sir.
Okay, one second. Tish, if you are able to hear me, video should be on while you are in the class.
Yes, sir.
Yes, why is your video off still?
I'm dying, sir.
Traveling to? Okay, whatever. Please come back. Please pay attention. So I was talking about the flow of charges. So I said that charges, if they are at rest, then there is no current. But same charges, when they start to move, it makes current. If it is a movement of positive charge or it is a movement of negative charge, both will produce current, both will generate current. Remember that. Because I have seen many students understanding current as rate of flow of electrons. It's not that. It's rate of flow of charges. Difference is direction of current. If the charges are flowing, are positive, will be same as the direction of protons. And if it is current produced by the movement of electron, direction of current will be opposite to direction of electrons. This current is called as electronic current and this current is called as conventional current. So conventional current is the current produced by the movement of positive charged particles and electronic current is the current produced by the movement of negative charged particles. Again, if I say you there is a charge, then the first question that should come to your mind is, what is the value of this charge? If I have 1 proton, 2 proton, 3 proton, 4 proton, 10 proton, 10 to the power 6 proton or 10 to the power 25 protons or 10 electron, 50 electron, 1000 electron, 10 to the power 67 electron, whatever you have, what is the charge it can create? That is given by quantization. That is, it is fixed that how much charge is there on a particular proton or electron. That is called as basic elementary charge. This word may not be there in your NCERT book, it will come in a higher class only. But remember that, what is the meaning of the word basic elementary charge? Basic elementary charge. It is denoted by the letter small e and its value is plus or minus 1.6 times 10 to the power minus 19 coulomb. What does it mean? It means that if you are having 1 proton or 1 electron, it carries a charge of 1.6 times 10 to the power minus 19 coulomb. If 1 proton carries this much charge, if you have 10 to the power 5 protons, how much charge it will carry? This much multiplied by 10 to the power 5. Ask me.
6.25 to 10 power 18 the value.
Its value of? It is actually 1 coulomb of charge has how much electrons? That is what you are saying is the answer for that question. If I take, I will write the formula now. Q is equal to Ne, and if I take Q as 1 coulomb, 1 will become equal to what? N into 1.6 times 10 to the power minus 19. So what will be N? 1 divided by 1.6 times 10 to the power minus 19. When you solve it, it will become how much? 10 to the power how much?
18.
Not coulombs, it will be charges, that is protons or electron, whatever you want to call it. This is the value of N. Are you getting what is N? 6.25 10 to the power 18 is the number of charged particles required to create 1 coulomb of charge. Are you getting my point? I will come to that. So this is the basic elementary charge. So the formula of total charge is given by Q is equal to Ne. This is only called as quantization. Q is equal to Ne. It means if you have n number of charged particles and you multiply this n with E, which is this, you are going to get total charge produced by so much amount of particles. Is it clear to you? Like simple, 1 banana costing 10 rupees, so 100 bananas will cost 1000 rupees. Same logic. If 1 charge is having, or 1 proton or 1 electron is having this much charge, then n protons will have n into this much charge. Same logic I have applied. And this plus or minus denotes that, yes, if it is plus 1.6, it is a charge produced by a positive charge, proton. If it is minus 1.6, it is charge produced by an electron. So plus or minus has nothing to do with the magnitude. It just denotes that this charge is produced by a electron or by a proton. This defines what is charge. And then comes the current definition. Current, I said, use the flow of charges. Mathematically, current is given by charge per unit time. That is Q by T. That is the definition, that is the formula of current, which is charge per unit time. Charge is in coulombs, time is in seconds. Coulomb by second is also called as amperes. So SI unit of current is ampere, and 1 ampere is equal to 1 coulomb by 1 second. This definition may come in the school examination. Define 1 ampere of current. If 1 coulomb of charge flows through a conductor in 1 second, then the current produced is 1 ampere. This kind of question is commonly coming in the school examination. Define 1 ampere current. 1 ampere is that current produced when 1 coulomb of charge moves across a conductor in 1 second. Okay. One more thing comes from here. This Q is equal to NE, a very common question I have told you in the regular class when I was teaching this topic also. That question comes whether this much charge is possible or not. That is, they will give the value of Q. They will say Q is equal to 3.2 times 10 to the power minus 20 coulomb. Is it possible? This kind of question comes. How to check whether it is possible or not? For checking that, we will use the same formula, Q is equal to NE. We will find N. N must be an integer. Never forget that. If N is coming as a decimal or fraction, not possible. It's a common question in the board exam itself. They will give the value of Q and they will ask you whether this much charge is possible or not. How will you find? N will become equal to Q by E. Q is 3.2 times 10 to the power minus 20. What is E? 1.6 times 10 to the power minus 19. This will make it 10 to the power minus 1 times. This will make it how much times? 2 times. 2 into 10 power minus 1 will become 0.2. Am I right? Am I right? 2 by 10, 0.2. Is 0.2 proton possible? Can we have 0.2 electron? No. This charge also is not possible. Don't think any charge is possible. Charge is possible only if it is an integral multiple. What is the meaning of integral? It should be an integer. It should not be a decimal or fraction. This kind of question is common in the examination, where they will give you the value of Q and they will ask you whether this charge is possible or not. What they are asking indirectly to you is find N, verify. If N is a decimal, not possible. If N is a integer, possible. Many students will do a mistake, like they will get Q is equal to, here what we got, 2 into 10 to the power minus 1, right? They will see 2 and they will write possible. They will forget to mind minus 1. This is done by many children. One more mistake they will do. I will tell you what mistake they will do. If I tell Q is equal to, suppose 2.3 into 10 to the power minus 15 coulomb possible, then what they will do, they will solve this, they will get the value of N as how much? Q by E. Q is 2.3 times 10 to the power minus 15 divided by 1.6 times 10 to the power minus 19. They will solve this, they will get some fraction, right? 23 by 16 will be some fraction. So they will get the answer as 23 by 16 times 10 to the power, this will become 19, right? So 4 will become. What they will think, they will just see this answer, fraction, they will write not possible. They will forget to mind 10 to the power 4, which when you multiply will get a integer. 10 to the power 4, right? 1, 0, 0, 0, 0. 16 will cancel that. You are going to prove it. 23 by 16 times 10 to the power 4, right? How many zeros are there? 4 zeros. Check. 4 fours are 4, 2, 4, 5, 0, 0. Once again 4. 6 24. 1, 0. 4 2s are 8. 2, 0. 4 5 are 20. Multiply, it will be integer only, no? 625 times 23 is going to be integer only. Possible. But what students will do? They will see this 23 by 16. Looks like a decimal. They will write not possible. Again a mistake. So either missing in this way or writing in this way, both can lose marks for you. Are you getting? Seeing this 2 and deciding it is a integer, or seeing this 23 by 16 deciding it is a fraction, both ways you will lose marks. Be careful. See, I am pointing out the place where you will make a mistake. From my experience of teaching, I am telling you. I have seen so many people writing like this and making mistake here. Is it clear to you? Concept of quantization is clear. Am I audible now, Preetham?
Yes, sir.
Yes. So second category of question is from this I is equal to Q by T, or they may give current, they may give time, they ask how many electrons have produced this current. So you will multiply I, multiply T, you will get Q, and then divide by E, you will get N. This kind of questions are also very common in school examination. Now, any student who is weak in division, multiplication, power, exponents, they'll do mistakes here. So I have seen many children losing marks. You know why? They are not knowing how to divide 23 by 16. That's the situation today. You are in 10th standard, but you don't know how to divide, how to multiply. They'll confuse 10 to the power minus 1 plus 1, like that they'll confuse. Like I'm writing this step, no. This cancellation they'll do mistake. 10 to the power minus 1 can be written as 1 by 10 also, they are not knowing this, unfortunately. And that's why they're losing marks. If you are in that category who is having trouble in multiplication, division, handling powers, learn that. We will arrange class for you, a separate basic math class where we will teach you these basic things. But don't avoid this. You cannot escape from this, because these kind of questions are going to come in the examination. Coming forward. Okay, please pay attention. So we came to know now that if you are going to have charge which moves, it is going to become current. Right? Charge which moves, whether it is electron moving or proton moving, you are going to get current. That is known to you now. Right, Mr. Priyaranjan? Saw the dream? Saw the dream, no? Come out, man. Be alive and live, whatever. So next is how the charge can move from one place to another place. We came to know that if charge moves, it produces current. But how can charge move? Charge can move with the concept of potential difference. So potential difference should be very clear to your mind. What is the meaning of the word potential difference? Because many will not understand this. Any metal you take, any conductor you take, it will have free charge particles. Are you aware about that? That's how we define a conductor. What is the meaning of conductor? They will have free electrons or free charge particles. That's why they are called as conductors. Are you getting my point or not? If there is any conductor, like we have aluminum rod, is it a conductor or insulator? Conductor means what? It will conduct heat or electricity, right? If I take wood, insulator or conductor? Why? It will not conduct heat or electricity. If I take plastic, insulator. How you are deciding this? You are thinking whether something is able to conduct current or not, isn't it? Am I right or not? A particular element is conductor or insulator. Who decides that? It is decided by its conductivity. If it can conduct, and how it can conduct? By the presence of free charged particles, right? So suppose this TV, if you see, this frame is aluminum frame, top, it's aluminum. Now this aluminum is having free charged particles, right? Those free charged particles, do you think they are at rest? Never. They are in random motion only. They will be in motion only. Now if it has charged particles and those charged particles are in motion, why I am not getting current when I am touching this? Is my question clear to you? Because the electrons are not moving in a specific direction. They are randomly moving. Suppose I am having a conductor like this and the charged particles are moving randomly. Then the net effect will be zero. They will cancel each other. That's what is happening in this wire, this aluminum bar. This is also aluminum only. So if you have metals, what that door handle, it's metal, aluminum. Touch it, you will get current. Never. Why? Because even though free electrons are there, even though free electrons are moving, they are not moving in a specific direction. They are randomly moving here and there, producing no current. But if somehow I make the electrons to move in a particular direction, it will give current. Then touch it, you will get a shock. Because now current is flowing. As of now, there is no current because electrons are in random motion. So potential difference is provided to make the charged particles move in a particular direction. And how it is done? Let me talk to you about the concept of potential difference. I have told this many times in the class also. Like if you have to get water in your tap, what do? You put water in the tank, isn't it? If there is a water in tank comes from tank to your tap by itself, because tank is at higher potential, tap is at lower potential. It automatically flows from higher potential to lower potential. Suppose you are cooking, okay, and you are cooking, mom is cooking, whoever is cooking. So you have a vessel, okay, and you are having a spatula. What do you call it? Karandi in Hindi, Tamil, I think. So that by that using that karandi you are making water. Oh, you want water? Go and drink water. What is this? Ask properly. Water. What I should understand. Go and drink. Come fast. Will you go today? Fast, man. Okay. So I was saying that if you have a spatula, that is karandi, and you are cooking something, you would have felt that that spatula will become hot in some time. Why? Because you are saying metals will conduct heat. See, think in this way. Your spatula is initially cold, normal temperature. When you are touching with the vessel which is on fire, that part is hot. So always heat flows from where to where? Hot to cold. Hot means higher potential, cold means lower potential. Once again, heat also flows from where to where? Higher potential to lower potential. Naturally, everything in the universe always moves from where to where? Higher potential to lower potential. One more example can be this. I have told this example already in the past also. That if this is a platform and I keep an object here, it may not move because both the potentials are same. But the moment I increase one potential, it starts to move because it travels from where to where? Higher potential to lower potential. If you want this pen to move from lower to higher by itself, can it move? Never. If you want this pen to move from this point to this point by itself, is it possible? Never possible. Possible only if you give some force here, isn't it? The same thing happens in the case of current also, which is, if you want these electrons to move in a particular direction, what you should connect? A potential difference. And a potential difference is just a battery which is having a positive terminal and a negative terminal. This is how we represent a cell, right? I hope you know that a cell is represented like this, a small line and a longer line. Smaller line is negative and longer line is positive. Positive means what? Positive means higher potential and negative means lower potential. The moment I create a potential difference in the circuit, automatically the charged particle starts to move from where to where? Higher to lower. Automatically. Because I have given a potential difference, automatically all the electrons starts moving like this and starts to come and reach here. Problem is when the electrons will reach here, because now it is in lower potential. Something like my pen came down. Now from lower it has to go to where? Higher once again. That is the challenge. It cannot do by itself. Then what will be used? Chemicals inside the battery will be used. See, this level of concept no is only there in 12th standard. I am telling you now to make it clear for you. It's not there in 10th standard itself, the chemicals role in the battery. But I am telling you, because chemicals inside the battery, what they do? They provide the chemical energy for the charged particles to move from where to where? Lower potential to higher potential. Once again, higher to lower, it will go by itself. So whenever we are creating potential difference, why we create it? For making the charged particles to move from one place to another place in a particular direction. And that's how the current is produced. Now, the moment I connect a battery, all these electrons will align itself and will move like this, you see. One direction. Are you getting my point? If everything is moving in one direction, then there will be a current produced. Okay? That's how the current is produced. Now, if you see, if you think like why I have drawn in this direction, because it is electron and current is in this direction. Current direction is always opposite to direction of electrons. That's why I have drawn in the opposite direction the electron. If I am drawing protons, I will draw in the same direction. So that is how the current is generated with the help of what? Potential difference. Mathematically, what is potential difference? Potential difference is defined as work done per unit charge. Work done per unit charge is known as potential difference. Definition, proper definition is work done per unit charge to move it from one point to another point is called as potential difference. And what is the unit of work done? Joules. 9th you studied this, no? In 9th you studied this. Charge is in coulombs. Joule per coulomb is also called as volt. Now you will have a question in the examination. Define 1 volt. 1 volt is that potential which is produced or which is created when 1 joule of work is done to move 1 coulomb of charge from one place to another place. 1 joule of work is done to move 1 coulomb of charge from one point to another point, then the potential difference is 1 volt. Is it clear to you? I hope the definition of 1 volt is clear to you. Okay. Then comes the questions from here. From here also you will get numericals. Remember that. How the numericals will come? There they will give you work done, charge, ask you to find potential difference. They may give you potential difference, charge, ask to find work done. Never forget that Q is equal to what into what? N into E. So anyway the question can come. They will give you N value, they will give you work done value, they will ask potential difference. Don't confuse. If N is given, you can find Q easily by multiplying with E. That kind of questions will come in the examination. Is it clear to you? Then next topic in this chapter, which I have not talked in the regular class, is about electrical symbol. Electrical symbols. So you must know some basic symbols in the circuit. For example, what is this? No battery, cell. Single is called as cell. And if I have collection of cells, it will be called as what? I have seen students studying in 10th standard, they are not going to draw this diagram also. Many are not knowing how to draw this diagram. They are drawing something randomly. See, there is a way of drawing, no? Never forget one negative, one positive. Then one negative, one positive. If you draw like this, no? They will not give marks now. When you write a negative and a positive, then must be negative, a positive, and goes like that. Is it clear to you? Negative, positive should always be connected in the same way. Don't connect negative, positive, positive, negative, negative, positive, positive, negative. It will not fetch you marks. Be very, very careful how I am drawing a battery. I am drawing a battery by connecting negative, positive, negative, positive, negative, positive. Is it clear to you? Then next symbol I can draw is of this. What is this? Tell me. Off or on? Off. This can also be drawn like this. They both are off switch. Switch is off means current will not flow because circuit is incomplete. What is this? Switch on can also be represented like this. This is switch on. That is, your circuit is working. It is closed circuit. We call it as closed circuit. This is open circuit, which is switch off, and this is switch on. What is this? Voltmeter. Voltmeter. It's voltmeter. Voltmeter is used to measure the potential difference. And always remember, whenever you draw voltmeter, a minus and a plus is compulsory. It means that negative and positive terminals are important. In a circuit, if I connect voltmeter like this or connect like this, they will not work. If it works in this way, it won't work in this way. Are you getting what I am trying to tell you? Negative and positive of the voltmeter is fixed. You cannot interchange it. Same way, if I have a ammeter, it is fixed, negative and positive. But if I have a galvanometer, not fixed. Galvanometer can be connected like this also, like this also. I'll repeat this. I'll tell all the three now. Voltmeter is used to measure the potential difference. Ammeter is used to measure the current. Galvanometer, on the other hand, is used to detect the presence of current. I'll tell you what is the meaning of that. Generally, when you see ammeter, have you seen ammeter in school? No, not yet. Will you see in 10th standard or will not see in 10th standard itself? You will not see. Why? No, don't have an experiment in physics lab? You are having an experiment, but they will not do in school. They will put in the board itself, not practically. Okay, let me tell you. If you see a ammeter, it looks like this. It will have a scale, it will have a needle, and it will have like 0, maybe 5, 10, 15, 20, 25, like that. So imagine, see something very conceptual I am telling you now, please pay attention. 0 to 5, we will have some 10 division in between. In between we will have some 10 division. It means the lowest value which the ammeter can measure is 0.5 ampere. Do you agree with me? 0, 5, 10, 15, 20, like that. Between two, how many we have? 10 divisions we have. So 0 to 5, if we have 10 divisions, if my needle goes to the first division, how much it is measuring? 0.5 ampere, right? If the current in the circuit is 0.1 ampere, what will happen? It will not measure it, because the minimum it can measure is how much? 0.5 ampere. If I am giving 0.01 ampere, what will happen? So current came inside, but ammeter showing no deflection. This problem is solved by whom, you know? Galvanometer. What galvanometer is doing? It looks like this. Center needle will be there, here plus, here minus. Even 0.00001 ampere current comes, no, it will deflect. Very feeble current also, your needle will start shaking, showing that some current has come inside. That's why I told galvanometer is used to detect the presence of current, whereas ammeter is used to measure the current. Are you getting my point? Galvanometer will detect the presence of current, but ammeter will measure the amount of current, how much current is coming inside. Is it clear to you? We have something like this. What is this called as? Resistor. What is this called as? Any idea? What is this? Some books will also write like this.
Sir, rheostat.
Variable resistance. Yes, very good. It is called as variable resistance, also called as rheostat. Rheostat is a device where you can control the resistance. Whether I am going to give 2 ohm, 3 ohm, 5 ohm, 10 ohm can be controlled by that. That's why the name is variable resistor. Variable resistor. This is a fixed resistor. If it is 2 ohm, it will be 2 ohm only. But this can be changed based upon where you are keeping the jockey. This jockey, wherever you change, the value of resistance will change. This is called as variable resistance. What is this called as? Any idea? Earthen, good. This is called as earthen. Now what is earthen? For safety purpose, we are always giving earthen connection at the top, which is connected to the earth. If any excess current comes, it is sent back to the earth. Okay. What is this? Any idea? Joint? Good, Kritikeshwaran. It is called as joint wire. So what is the meaning of joint wire? Okay, what is this then? Unjoint wire, correct. This is called as joint wire, and obviously this will be unjoint wire. Okay, now why we are learning this? I'll tell you. Please pay attention. Where are we going to use all these things in real life, you know? In circuits, electrical circuits. See, when you make big buildings, Don't think that some people will go, they will construct, they will make all the concrete, everything, and the building will be ready. Building making is a very big process. Imagine buildings like Burj Khalifa. That is so complex building. It took almost $2 billion to make that building. And that building, whenever a building is planned, the first work is soil work, the testing of soil, all these things. Second work is electrical work. So they will make electrical drawings of the whole building. When they make electrical drawings, lot of wires will be going here and there, right? In this room itself, you can see so many wires going here and there. So many wires are there. When somebody is making electrical map of this room, and there are two wires crossing, suppose there are two wires going. Now there is a possibility that two wires are going like this. One wire like this, one wire like this. They are touching each other? No. Or two wires may be going like this, joint. Now, if I am drawing in a paper, this or this, both will come like this only, no, for me. Are you getting my point or not? If I am drawing this wire, I am telling you draw this. What you will draw? One line, one horizontal line, right? If I ask draw this, once again one vertical line, horizontal line. How do you distinguish whether they are touching or not touching? That's why we do this. If I draw a dot here, it means they are touching each other. If I draw a hook like this here, it means they are not touching each other, unjoint wire. Is it clear to you? That's why I use this symbol, joint wire, unjoint wire. So all these symbols are clear to you. I hope it is clear. Some more things are there, not required for you much. What is this? Bulb, isn't it? What is this? Any idea? Not galvanometer, that is already over. This is generator. Same way, if I am having M, it will be motor. These things are not there in syllabus for you, but they are used in the symbols. Okay. So I am moving forward, and next topic that comes in the syllabus is Ohm's law. So this physicist or scientist, whoever, whatever you call, Ohm, what did he do? He derived a relationship between potential difference and current. Did series of experiments where he took a circuit. This circuit, he had a resistor. Always remember that ammeter is connected in series and voltmeter is connected in parallel. Never forget this. Never ever forget this. Voltmeter is connected in parallel, ammeter connected in series. To what? To resistance. So I am keeping an ammeter here in series, and I am keeping a voltmeter here in parallel. And here I am having battery. Okay, diagram is clear to you. I am having a circuit where I am having a resistance, I am having a voltmeter, I am having an ammeter, and I am having a battery. Okay. Now what did Ohm do? He kept on changing the batteries, that is 1 cell, 2 cell, 3 cell, 4 cell, 5 cell. It means he kept on increasing the potential difference. And he checked for this potential difference increase, how much is the current varying. Is it clear to you what he did? He took a resistance. On that resistance, he connected a voltmeter, series ammeter, and then connected a battery here. Battery kept on changing. First use 1 volt battery, 2 volt battery, 3 volt battery, 4 volt battery, 5, 6, 7, 8, 9, 10. Many batteries he changed. And he studied for this battery, what is the reading of voltmeter, what is the reading of ammeter. So for each reading, he kept on testing what are the values of voltmeter and ammeter. Which room here? Above this? That, okay, I understood. One second. Is the room opened?
Yes, sir.
You don't want key, right?
No, sir.
Okay. Yes. So what, coming back please. So when he kept on changing the battery, he observed that as the potential difference was increasing, the current was increasing proportionally. What is the meaning of proportionally? You know, if it is 2 and if it is 4, it is 3, it is 6, it is 4, it is 8, it is 5, it is 10. So there is a relation which is proportional. How it is increasing? In the same order current also is increasing. This proportionality, when you draw in a graph, it will become a straight line. This is the graph of proportionality graph. So this was the finding of Ohm. Ohm told that the potential difference across a conductor is proportional to the current flowing through it. And when you remove proportionality, you have to add a constant. That constant is called as resistance R. So V is equal to IR. That's how it came. And what will be R then? R will become equal to V by R. V is in what? Volts. I is in what? Amperes. Volt by ampere is called as ohm. And that's how we define 1 ohm. See, we already defined 1 ampere. We already defined 1 volt. Now we are defining 1 ohm. 1 ohm will become equal to 1 volt by 1 ampere. These things are really important for a school examination. 1 ohm is 1 volt by 1 ampere. One very important information, please pay attention. Since R is equal to V by I, you can see very clearly it says that slope of VI graph gives what? Gives resistance. This will come in the examination. Slope means what, you know? What is the meaning of slope? Have you studied in mathematics? What is slope? Y-axis by? Yes, actually you are right. Y2 minus y1 by x2 minus x1 is called a slope. Or we can find by using tan theta if you have learned trigonometry. Tan theta also will give you slope. In simple layman's word, if I say the inclination of this line with current axis, not the x-axis, that gives you slope. So if I am drawing two lines, wire A and wire B, which wire has more resistance, A or B? Why do you say A? It has more slope, that's why it has more resistance. Common sense, true. But same question, if I ask you, but I am putting current here and voltage here, now same A and B. If I ask you, which wire has more resistance, what is the answer now? B. Because you will measure slope from where? From current axis, not the x-axis. So here slope is less, here slope is more. So which has more resistance? Wire B. Be careful, this kind of question will come in the examination where they will give you multiple lines and they will ask you which wire has more resistance. This graph based question has come in the board exam also. Go and check your book. So be very careful about it. You will get questions from here also. Is it clear to you? Is it clear to everybody? So I am winding off today's class with some topics remaining in this chapter: resistance in series and parallel, power, heating effect, all these things, which I will be doing in the next class. But before that, once again remember, tomorrow you will have a class, practice class, where you will be given some questions. Please solve the questions based upon this chapter. Then only you will get more confidence. Okay. Once again, before you drop down, I will take the attendance before you leave. Give me a second. Yeah.